After completion of the monosaccharide, our next topic, that is disaccharide. How does formation of disaccharide? When two same or different molecule of monosaccharide joint with the specific chemical bond, structure come into exist, that is disaccharide. What is this? The name of this chemical structure. First carbon here present, HOH. Second carbon HOH, third carbon OH, fourth carbon HOH, fifth carbon H inside, and sixth carbon enter outside, that is CH2OH. Same here. We draw 6 ring structure out of 6. Here, check it. What is the name of this chemical? What is the name of this chemical? Both are same. This is alpha D glucose. This is also alpha D glucose. Alpha D glucose, we have to join. See here, first carbon OH present, and second molecule, then fourth carbon OH present. Between two glucose, chemical bond established. First carbon OH, there hydrogen, as well as second sugar, fourth carbon OH. H and OH get separate, so water gets separate between the two chemicals. So water molecule release outside. So procedure happen, that is dehydrolysis. Dehydrolysis. Now first sugar attached to second with oxygen present between first carbon and fourth carbon. So chemical bond established between the two sugar. Carbon, oxygen, carbon. Carbon, oxygen, carbon category of chemical bond is, can say, glycosidic bond. Glycosidic bond. This is the first carbon, second, third, fourth, fifth, and sixth. First carbon, second carbon, third, fourth, fifth, and sixth. So alpha D glucose plus alpha D glucose. Out of any sugar, hydrogen, as well as any sugar, OH. Water release outside, chemical bond established, carbon, oxygen, carbon, that is glycosidic bond. What is the position of glycosidic bond? So both alpha sugar and having a bond between first carbon to fourth carbon. That's why position of glycosidic bond, there is alpha 1 to 4. Very important question. Here chemical bond position, what is alpha 1 to 4? Why alpha 1 to 4? Because both chemical in alpha position. Bond formed between first carbon to fourth carbon. Glucose plus glucose give rise which chemical? This is maltose. Maltose is one of the example of disaccharide. So entire chemical reaction completed, that is alpha D glucose plus alpha D glucose is equal to maltose plus water. Maltose plus water. Now, this chemical reaction, that is reversible also. Here we wrote glucose plus glucose give rise maltose plus water. Now reverse, maltose plus water means hydrolysis of maltose. Maltose plus water give rise building block of maltose disaccharide into monosaccharide glucose plus glucose, and this procedure is hydrolysis. There is one type of digestion of maltose into glucose plus glucose in presence of water. Maltose were present, so in a seed of a plant there were starch digest. Starch is the example of polysaccharide. Starch digest in germinating seed. In germinating seed, starch digest from what? Maltose. That's why maltose is also can say malt sugar inside the seed. That is malt sugar. Okay, one type of disaccharide we completed. Now what is the definition of disaccharide? When two same or different monosaccharide join with the help of glycosidic bond by releasing of one molecule of water, the structure come into exist, that is the disaccharide. Now if we change the monosaccharide, so disaccharide also change. Okay, we are now going for the next example of disaccharide. Now you know clear cut what is the name of this chemical and what is the name of this chemical. Because you having already ring structure at the previous lecture. This is beta D glucose and this is beta D galactose. First carbon OH, H, OH, second carbon, third carbon, OH, fourth, OH, fifth one, hydrogen, as well as sixth carbon outside, beta D glucose, first carbon, OH. Now chemical bond established by removal of one molecule of water, hydrogen from one monosaccharide and OH group from another monosaccharide. Reaction between these two, water release, left what? Oxygen that join first carbon to fourth carbon of different two sugar. So this is the oxygen left. Carbon, oxygen, carbon. Which chemical bond form? Carbon, oxygen, carbon. So that is glycosidic bond. Glycosidic bond. What is the position of glycosidic bond? So that is both the chemical beta. So that is beta 1 to 4 linkage. 1 to 4 linkage. Now chemical structure come into existence. That is lactose. And lactose is present within the milk. That's why there is can say milk sugar. Lactose is milk sugar. Sweetness of milk is due to the presence of lactose. Maximum lactose present inside human milk, that is 7%. 7% in a component of human milk. There were lactose. Milk of different animal. There were maximum lactose present in a human milk. There is how much? There is 7%. Now, this reaction is also reversible. First reaction, galactose plus glucose give rise lactose plus water. Beta D galactose plus beta D glucose give rise what structure? Lactose plus water. Lactose plus water. This reaction is also reversible. Lactose plus water. So give rise building block of lactose, that is glucose plus galactose. This is hydrolysis and this is dehydrolysis. It means this chemical reaction which is reversible. So we prepare two types of disaccharide. First maltose, there were position of glycosidic bond alpha 1 to 4. Now prepare lactose, their position of glycosidic bond. Very important question. Beta 1 to 4. Beta 1 to 4 linkage also we can explain. Now once again we change here the disaccharide. So here once again we change here the monosaccharide. So here change disaccharide. Alpha D glucose linked with the beta D fructose. So we obtain third category of disaccharide, that is sucrose plus water. What will linkage? Alpha D glucose having a first carbon, there were OH present downside, and beta D fructose, their second carbon, OH present upper side. That you know clear cut. So glucose first carbon linked with the fructose second carbon. So in sucrose, position of glycosidic bond, that is alpha 1 to beta 2. Why we mention in sucrose glycosidic bond position alpha 1 to beta 2? Because here two different chemical use. One alpha position, second beta position. Here first carbon linked to here second carbon with the glycosidic bond. So sucrose, very important. Once again MCQ. What is the position of glycosidic bond in sucrose? So that is alpha 1 to beta 2. Now sucrose present inside the sugar cane. That's why there is cane sugar. That is we use in our household purpose. That's why there is table sugar. We have to buy this from the market. That's why there is commercial sugar. Commercial sugar. Sucrose made up of two opposite molecules. One glucose and second fructose. Head that rotate the plane polarized light in different direction. That's why sucrose is invert sugar. Now next categories of disaccharide. Alpha D glucose react with alpha D glucose. Only one time write the reaction. Now second time. See alpha D glucose joined with the 1 to 4. So maltose obtained. But alpha D glucose joined to alpha D glucose. First carbon to first carbon. How this possible? How to link these two different glucose? First carbon of one glucose linked to first carbon of another glucose. How? First glucose write as it is. Second glucose rotate. So two glucose first carbon remain nearest to each other. Both the carbon having OH group. Water gets separate. So obtain what? Trehalose plus water. Trehalose. What is the glycosidic bond position in trehalose? So alpha 1 to 1. See alpha 1 to 4. Alpha D glucose plus alpha D glucose joined alpha 1 to 4. So there is maltose. Same glucose but joining different 1 to 1. First carbon joined to first carbon. So trehalose. Trihalose were present. So that is present inside the hemolymph of insect. Hemolymph of insect. Is our blood having a glucose more? Same, blood of insect, that is can say hemolymph, and in this hemolymph trihalose sugar present. All the reaction which is bidirectional, now at presently we produce 4 types of disaccharide, that is maltose, lactose, sucrose as well as trihalose. If we react maltose with the enzyme maltase, maltose react with water in presence of maltase, so we can get glucose plus glucose. Similar way, lactose react with the water with the help of enzyme lactase, so we can get glucose plus galactose. Sucrose with water reaction in presence of enzyme sucrase. Also we can write invertase. So gets what? Fructose plus glucose. Trihalase, enzyme trihalase. So trihalose react with the water. And produce glucose plus glucose. So all disaccharide which is split into monosaccharide, disaccharide digest into monosaccharide with the corresponding enzyme. Or other option is also there. If we have to not use the enzyme, so we have to boil all in slight acidic medium. In dilute acid. In the dilute acid solution, boil. So maltose, lactose, sucrose, trihalose split in acidic medium with provide slight temperature, so converted into their building block. We know the empirical formula of all. C6H12O6 plus C6H12O6 give rise water between these two. Now whatever the left, right? What is left that we mentioned? Carbon 12, hydrogen 24, 2 minus from here, so 22. Oxygen 6 plus 6, 12, 1 minus 11. So empirical formula. Formula for any disaccharide, that is C12H22O11. This is the empirical formula of any category of disaccharide. Now we write general formula. General formula for disaccharide. See here, this is proportion hydrogen to oxygen, that is 2:1. And oxygen, one number more than that of what? Carbon. So, Cn H2O n minus 1. Now take n is equal to 12. So 12 here, 11 here, 22, 11. Now we are mentioning here the properties or the characteristic of any category of disaccharide. Properties including solubility inside water, sweet in taste, as well as any disaccharide which is complex than that of monosaccharide. So cannot cross plasma membrane. If disaccharide have to cross the plasma membrane, so they have to break into their building block, such as monosaccharides. Now we completing here this disaccharide, and simply we can explain. Glucose plus glucose is equal to maltose. Galactose plus glucose is equal to lactose. Glucose plus fructose is equal to sucrose. Glucose plus glucose but joined one carbon, first carbon to first carbon, that is trehalose. Carbohydrate having the two types of chemical group, aldehyde and ketone group. Some carbohydrate, this both the group free, so they can carry out the reduction. That's why they are reducing category of carbohydrate, sugar. And some having a not this group free, so not carry out any reduction type of reaction, so they are non-reducing carbohydrate, sugar. Now, given carbohydrate which is reducing or non-reducing, how we can get this information? Though carbohydrate having a aldehyde or ketone group, in chemical reaction they converted cupric ion into cuprous ion, means Ca plus Cu plus plus to Cu plus. So they are reducing. Though carbohydrate having no aldehyde or ketone group free, so they cannot reduce cupric ion into cuprous ion, so they are non-reducing. Two types of solution is there. One Benedict solution for Benedict test and second Fehling solution for Fehling test. Both made up of cupric Cu++. Now unknown carbohydrate, whether to check reducing or non-reducing, so we add this solution of unknown sugar into either Benedict or Fehling solution, and then slide we warm this test tube. So if color of test tube change from normal to reddish or brick red in color, so they were converted cupric into cuprous and given sugar, that is reducing. In diabetes patient, within urine, glucose present, that can be tested with the help of either Fehling or Benedict test. The person having a doubt, having diabetes or not, so take their urine sample. This urine mixed with the Fehling or Benedict solution. Slight warm. Color of solution remain as it is, so glucose absent. But color of within the test tube change into red or brick red in color, so glucose present. Now we know clear cut, all monosaccharide having a aldehyde and ketone group free, so all monosaccharide are the example of reducing sugar. Now disaccharide, we know clear cut, in disaccharide structure of maltose and lactose. At first carbon, this side, CHO group free, so maltose and lactose, that is also reducing. So all monosaccharide plus disaccharide, which is maltose and lactose, that is reducing. Now non-reducing. See here, sucrose. Sucrose, how does prepare the sucrose? So glucose first carbon linked with the fructose second carbon. Glucose first carbon having aldehyde group linked with the fructose second carbon ketone group. Both the group linked to each other, so not free. That's why sucrose is the example of non-reducing sugar. Same way check trehalose. One glucose first carbon aldehyde, second group was first carbon aldehyde. Both the glucose joined, so aldehyde group joined, aldehyde group not free. So trehalose also non-reducing. And all polysaccharide. All polysaccharide which is non-reducing. Non-reducing sugar which is chemically stable sugar, not immediately react in chemical reaction. Whereas reducing sugar which is chemically unstable, they are immediately used in chemical reaction. So plant transports sugar from leaf to the rest of the other part. So this sugar is what? Sucrose. Plant transports sugar as a which form? Sucrose form. Why? Because that is chemically stable because of non-reducing sugar. So now in today's lecture we complete already disaccharide, along with reducing and non-reducing sugar.